Today we're starting section 4.1, which is quadratics. So our very basic, our formula for a quadratic is y equals ax squared plus bx plus c. And this is our standard form. We're going to talk about graphing quadratics today that are in standard form. Our parent function is y equals x squared. So this is what's going to give us what pretty much all quadratics are going to look like. They're going to look like this with a little bit of variation according to size, how steep it is, kind of where it is on the graph. So if we start here, let's kind of plug in some values and see what would this look like. So let's look at -2, -1, 0, 1, and 2. If I plug in -2 in for x squared, that's going to give me -2 squared. So -2 times -2 is 4. If I plug in -1 in for x squared, I get -1 times -1 is 1. Plug 0 in, I get 0. 1 in, 1 times 1 is 1. And plug in 2, 2 times 2 is 4. So if I'm looking at its graph, we said at -2 I'm up here at 4. At -1 I'm at 1. 0 I'm at 0. 1 I'm at 1. And then 2 I'm also at 4. And so we're going to kind of connect our dots. If we plugged in 3 squared is going to be at 9. So it's way up here. So we know it's just going to continue on up. Okay, so this is what we call our parent function for quadratics. It is parabola shape, it's kind of a U shape, and pretty much all our quadratics are going to look like this. Now, if we just changed one thing, so I made it a negative x squared, how is that going to change my values? What we would have is for -2, the same points. Now I've got a negative in front of my -2 squared. Okay, so -2 squared is 4, so my answer is going to be -4. Now plug in -1, now I'm going to have -1, 0 is still 0, and now 1 I'd have -1, and 2 I'd have -2. So now all of my values became negative. So when I draw my graph, so at -2, I'm down here at -4, -1, I'm at 1, 0, I'm at 0, 1, I'm at 1, and then 2, I'm down here at 4. So my graph is going to flip over. I didn't draw that very good. That is going to be a U shape going down. So when we're looking at this number in front of our x squared, which in our standard form tells us it's an A value, the A value tells us which direction the graph is going. If it's positive, it's going to go up. If it's negative, it's going to go down. In these two examples, we didn't have a B or a C. Okay? Now, let's look at, well, what if I have a C value? Okay? So what if I had let's see, let's do 2x squared minus 3. Okay? So if I'm looking at these values, let's do the same, let's look at the same numbers. So say I've got, plug in -2, this is going to give me a 4, 4 times 2 is 8, minus 3 is 5. If I plug in a -1, -1 squared is 1, times 2 is 2, minus 3 is -1. If I plug in a 0, 0 squared is 0, times 2 is 0, minus 3, I get a -3. Now notice my -3 is the same value I have here. If you remember from linear functions, anytime we plug 0 in for x, that's going to give us our y-intercept. So this C value in all standard, in all quadratics, is our y-intercept. So it kind of gives us some information. Now you notice that both of these are symmetric around 0. And the same thing's going to be true here. When I plug in a 1, I should get -1. I should get the same thing I got for -1. So this is going to give me 2 times 1 squared minus 3. It's going to give me -1. If I plug in a 2, it's going to give me 4 times 2 is 8 minus 3 is 5. So again, it's going to give me, it's going to be symmetric. I've got a y-intercept at -3. At -1, I'm at -1. At 1, I'm at -1. At 2, I'm up here at 5. -2, I'm up here at 5. Okay. So notice on this one, it's not a very good curve, but my graph is much steeper than it was here. Because here I went from 1 to 1, there's just a kind of a jump of 1 here, and then a jump of 3, going from here to here. On this one, I'm jumping 2, and then I'm jumping 6. So this value in front of x not only tells you direction, but also tells you how steep our curve is going to be. So the larger the number is, the steeper it's going to be, mainly because you're taking a number that you're squaring and multiplying it by a number. So the larger this number is, the steeper it's going to get. So if you think of, if it's 10x squared, when you plug in a 1, now you're going to be all the way up here at 10. If you plug in a 2, it's going to give you 4 multiplied by 10, you're up at 40. So it's going to get very steep very quickly. Again, if we had a negative, it's going to go down. That also is true is if this number is small, say 1/2, your parabola is going to be wider. So let's look at one of those. So say we have y equals, well, let's make it -2. -1/2 x squared plus, we'll say 4. So if I plug in some points, let's do the same ones. If I plug in -2, -2 squared is 4, times a -1/2 is going to give me a -2. So I've got 4 times a -1/2 is -2, plus 4 is going to give me a 2. When I plug in a -1, -1 squared is 1, times 1/2 is -1/2, plus 4 is going to give me a 3.5. If I plug in 0, it's our y-intercept, so it's going to give me a 4. If I plug in 1, it's going to give me the same thing I had here, it's 3.5. If I plug in 2, it's going to give me the same thing I had up here as 2. Okay? So let's look. So I've got 1, 2, 3, 4. And then at -1, I'm at 3.5. At 1, I'm at 3.5. At 2, I'm at 2. If I plugged in, let's say I plug in a 4. Kind of come out here a little bit. If I plug in a 4, I would have 4 squared is 16, times -1/2 is going to give me -8, plus 4 will give me -4. So it's going to be, oops, -4 down here. Okay, so these are wider than the ones we did a little bit ago. Okay, now what if we have that b value? We said that our standard form was ax squared plus bx plus c. Now a tells you which direction you're going. If a is positive, it's going up. If a is negative, it's going down. If a is a large number, it's going to be very steep. If it's a small number, close to 0, it's going to be very wide u. Your c gives you your y-intercept. Now, one thing I didn't mention is this top point here. It's either the very tip top of our parabola or the very bottom. It's called our vertex. So this is our vertex. Notice on all the ones we've done so far, our vertex is on the y-axis, and it's symmetric around that. So we would call, in this case, our y-axis the axis of symmetry. Now, that's not always the case. If I have this b term, what it's going to do is move my parabola left or right. And so to find out what that is, or where that is, we're going to find our vertex using a formula. The formula is x equals negative b over 2a. So we're going to plug these values in. So I've got negative b. So let's say I have y equals x squared plus 2x plus 1. Okay? So my b value here is 2. I've got a is equal to 1. If there's nothing in front of our x squared, we're going to say it's a 1. And my c value is also 1. Not that we really worry about c as much in this case. So in this case, x is equal to negative 2 over 2 times 1. So here my my x value of my vertex is negative 1. To find the y value, what we do is just simply plug it in, and it's going to give me what my y value is. So if I plug in negative 1 for x, that's going to give me 1 minus 2 plus 1. It's going to give me 0. Okay? So now my vertex is the point negative 1, 0. So if I'm drawing my graph, I've got this point at negative 1, 0. Now I also know my y-intercept. My y-intercept is 1. If I plug 0 in for x, I get a 1. So I've got a y-intercept here at 1. Now we said that in this case, our y-axis was our axis of symmetry. Well, our axis of symmetry is always wherever your vertex is. So in this case, I've got this axis of symmetry right here. I'll even put a little dot here. This is my axis of symmetry. Whatever's on one side, it's going to be on the other side. So it's going to be symmetric. So if I've got this point, I also have this point. So it gives me some extra values. So say I plug in a 1 to give me another point. So if x is equal to 1, I'd have y is 1 squared plus 2 times 1. Oh, before I got my 2. So I've got 1 squared is 1 plus 2 plus 1 is 4. So up here at 4. And if I move 1 in this direction, I'm also going to have 4. So my parabola is going to look like this. Okay? Oh, let me move. So my parabola is going to look like this. So all it did was just kind of shift it over 1. Okay? So let's look at another example of that one. So say we have y equals negative 6x squared minus 4x minus 5. Okay? We said that my vertex is y equals negative b over 2a. In this case, my a is negative 6. My b is negative 4. So when I plug those in, I've got x is equal to the negative of b, which is negative of negative 4, over 2 times a, which is negative 6. So negative 4 times a negative 1 is a positive 4, and give me negative 12 on bottom. So I've got 4 over negative 12 is negative 1/3. So now I'm going to plug that in here. So my x value is negative 1/3, which I love fractions, so we want to make sure we have plenty of those. So let's plug that in. A negative 1/3. Okay. So here I've got negative 1/3 squared is going to be 1 over 9. And then I've got 4 times negative 1/3 is going to be a positive 4/3. And then minus 5. So negative 6 over 9, that 6 over 9 is going to reduce by 3's. That's going to give you negative 2 over 3. Okay, so negative 2 over 3 plus 4 over 3 is going to give me 2 over 3 minus 5. And so that's going to give me negative 4 and then 1/3. So I'm taking a negative 5, I'm going to add 2/3 to it. So we're just wanting to get, a relatively close approximation to that. Because since we're graphing it, whether you graph it at negative 4 1/2 or negative 4 1/3, it's not going to be really easy to tell. So let's kind of stretch these out a little bit. Because this is -6, so it's going to go down. It's also going to be very skinny. Okay, so I've got -1/3 for my x value. 1, 2, 3, 4. Let's go down a little bit more. So 1, 2, 3, 4, and 1/3. So we're about right here. Now we said that my y-intercept is at -5. So I've got 1, 2, 3, 4, 5. So if I moved over 1/3 this way to get -5, if I move 1/3 this way, I've got a -5. It's going to be right there. So let's plug in a 1 here. If I plug in a 1, I end up with, that's -6 minus 4 minus 5. So that's going to give me -15. So I only went to, what is that, 5, 6, 7? So like just to get to 1, it's way off my chart. So it's just going to be really skinny in here. It's going to look like this. Okay, so really all you need to do is be able to find your vertex. Finding your y-intercept is nice. It's kind of helpful. Be able to find at least 2 to 3 other points, and then you can graph it from there. Now, and one other thing your homework will talk about is finding your maximum or your minimum. This highest point here, this is your maximum value for your graph. Okay? So all you're looking for when you're finding maximum is the vertex. So you're just using this -b/2a, plugging in that, finding whatever x is, plugging that into your equation, and finding your y value. And that gives you your maximum point. In a case like, let me pull this one back up. In this one, where we had a minimum, this would be our minimum. Again, we're just looking for a vertex. You find your x value, plug it in. So your vertex is -1, 0, but also the minimum of the graph is -1, 0. So that's mainly the two things that we're doing with this homework, is just graphing your equations and find your minimums and maximums. Okay? So very good.